students, welcome back. Now this video onward we will discuss the further part of machine. So let's start. Students, what are levers? Levers are the simplest kind of machines which we use in our day-to-day life. So let's discuss this part in the detail. So what is a lever? Lever is a rigid straight bar which is capable of turning about the fixed axis. This axis moved over a fixed point, and that fixed point is known as fulcrum. Okay. Now, whenever lever is in use, this fulcrum does not move. It is fixed. Now, let's discuss the principle. Now, suppose AB is my rigid straight rod and this is a fixed point. So, this is my fulcrum. Suppose I am taking effort this side, load this side. Then the distance between fulcrum and effort indicate my effort arm. Same way, distance between fulcrum and load indicate my load arm. Now, lever works on principle of moment. Already in the fourth topic you have done, what is moment? Yes, it is force into perpendicular distance. Now let's discuss the MA based on this moment of the lever. Now students, again I am drawing this rod A, B. Here again I am taking effort and this side load. As earlier I discussed, suppose this is my fulcrum, then this part indicate effort arm and this part indicate load arm. So moment is force into perpendicular distance. So load into load arm will give me my clockwise moment, and same way effort into effort arm will give us the anti-clockwise moment. And you know the principle of moment, clockwise moment is equal to anti-clockwise moment. So when you transfer effort on the left hand side, you will get load upon effort. And that side, when you transfer load arm, so right hand side, you will get effort arm upon load arm. As earlier you have done, what is your load upon effort, students? Load upon effort is mechanical advantage. So when you substitute instead of this mechanical advantage, so mechanical advantage of the lever is effort arm upon load arm. Now, depending upon the position of fulcrum, there are three classes of lever. Let's discuss each class in detail now. Now students, whenever fulcrum is in between load and effort, then that kind of lever is known as class 1 lever. Okay, now so when you draw this figure in the straight line form, if AB is my straight rod, then this is fulcrum, this side it is effort, and this side it is load. Okay, now just discuss this example. In the seesaw, this fixed point indicate the fulcrum, one side the load is there, other side the effort is there. So this indicate class 1 lever. Same way the claw hammer, this part is a fixed fulcrum. This is the effort, and the nail which you want to remove indicate the load. In the scissor, this is the fulcrum. Handle part indicate the effort. The blade of the scissor indicate the load. So all these are the class 1 lever. Now first discuss class 1 lever in detail, students. Now students, class 1 lever. In this, now this indicate effort, this one indicate the load, and this is the load, and this indicate the fulcrum. Now depending upon the position of the fulcrum, pivot indicate the fulcrum, and here the resistance indicate the load, and pivot indicate the fulcrum. If pivot is in this position, just see this is an effort arm and this is a load arm. Almost both are equal. So when effort arm is equals to load arm, what will be my MA, students? You know MA in case of lever, as earlier I discussed, is effort arm upon load arm. When both are equal, your MA will be equal to 1. So in this, when exactly fulcrum is in between, lever can be used to change the direction of effort. But in this case, you just see your load arm is less, effort arm is more. So in that case, your MA will be greater than 1. So when this is the position, your lever worked as a force multiplier. Okay. In this case, your load arm is less, effort arm is less, and the load arm is greater. In that case, MA is less than 1. In this case, it acts as a speed multiplier. So what we have concluded, that class 1 lever, there are 3 possibilities depending upon the position of fulcrum. MA can be 1, greater than 1, less than 1. So it can act as a force multiplier, speed multiplier, or used to change the direction of effort. But everything depends upon the position of fulcrum. Students, whenever load is in between the fulcrum and the effort, then that kind of lever is the class 2 lever. So you can consider in this way. One side the fulcrum is there. One side the effort is there. And load is in between. Now, effort, the distance between this fulcrum and the load indicates the load arm. Same way, the distance between fulcrum and effort indicate the effort arm. What do you have observed in this case? Always effort arm will be greater than load arm. This indicates that MA in this case is always greater than 1. So, class 2 lever always act as a force multiplier. Understood? So, whenever the example of force multiplier is asked, class 2 lever is always a force multiplier. Students, whenever effort is in between the load and fulcrum, then that kind of lever is known as class 3 lever. So you can draw in this way. Fulcrum I am taking this side and I am taking load this side. Effort is in between. In this case, this part indicates your effort arm. Okay. And fulcrum to load, this part indicate your load arm. So what you have observed, students? Your effort arm is always less than your load arm. And you know that MA is effort upon load arm. So your MA in this case is always less than 1. So class 3 lever always act as a speed multiplier. So whenever you want to give the example of speed multiplier, class 3 lever always act as a speed multiplier. Students, now whenever fulcrum is in between, we have discussed it is class 1 lever. Whenever load is in between, it is class 2 lever. And whenever effort is in between, it is the class 3 lever. Apart from that, we have discussed that class 1 lever MA can be equal to 1 or MA can be greater than 1 or MA can be less than 1. So depending upon the position of fulcrum, if MA is equal to 1, it is used to change the position of the effort only, direction of effort only. If it is greater than 1, force multiplier. If it is less than 1, then speed multiplier. Same way, class 2 lever, always MA is greater than 1. So it always acts as a force multiplier. In class 3 level, MA is always less than 1, so it always acts as a speed multiplier. Students, thanks for watching this video. Hope you have understood whatever I explained. Then also, if you have any doubt, put your comment. And if you are new to the channel, share and subscribe.